which is at this end, but I'm all good now. Thank you, Juliana, for that introduction. And thank you so much to CREST for inviting the Shrewsbury Water Forum here this morning to collaborate in this Smart Rural event. We are really pleased to be here. Thank you also to everyone who's attending. I hope that you come away from today's talks and networking with lots of new ideas, lots of new ways of thinking about old ideas, and having met some really interesting people with a common interest on the networking platform. There are loads of people from all sorts of different backgrounds here, so I've tried to keep my talk quite simple, although there are some complex ideas in there. So my apologies if you think I'm either talking down or up to you. I'm hoping there's going to be something for everyone in the talk. Just briefly, if you're looking at my face and a very small set of slides, and you'd like to see the slides more clearly, there are 4 arrows just up and right from the slides that you can go to full screen on. Kat, if we could have the next slide, thank you. So my job in this first talk is to introduce you to the Shrewsbury Water Forum and talk briefly about Shropshire and the water resources that we have here, and then introduce very briefly some of the themes that other speakers will be talking about in more detail later today. So we've got 6 water themes that I'll briefly run through, and also touch on some of the interesting sort of technological advances that I'm aware of as I go through each theme. Next slide, please, Kat. I came to Shrewsbury not long after my degree in hydrogeology or groundwater science, and I now run my own business providing consulting services in the areas of land contamination and water. But what was it really that drew me to Shrewsbury? Well, there's an urban legend that in the 1970s/80s, a group of young hydrogeologists were looking for an ideal place to set up a consulting firm, and had hit on Oswestry as somewhere that was very close to their beloved rock climbing in Snowdonia, but also close to clients such as the Environment Agency and Severn Trent Water in Shrewsbury. However, their plans were foiled because the fax line didn't go as far as Oswestry, so they settled for Shrewsbury and set up some successful consulting firms. And various people left and set up their own firms. Various companies were bought out by multinationals. Other people left firms and set up more firms until we come to the present day. So currently in Shrewsbury, there are upwards of 12 different firms ranging from multinationals to freelancers and sole traders, with a particular specialism in water science and in groundwater science. So it's an interesting place if you're a water scientist. As the university came to Shrewsbury, we realised that 2 things. One, that while Shrewsbury is well known in our own industry for water science, in the sort of wider world, it's not particularly seen as a centre. And we realised that there was an opportunity to collaborate with the university and with CREST. And so the Shrewsbury Water Forum was born. And we're really very interested in promoting Shrewsbury as a centre for excellence in water science, both nationally and internationally, and to improve access to water science training and education, which is important, obviously, to us, but also to the university. And we would really like to see our sector thrive and grow in Shrewsbury, helping the sort of economic activity of the town, but also the wider sort of community and environmental benefits that come from an environmentally aware sector, but also a sector that can create jobs and thus help the community. So we've been very interested to collaborate with the university. I'm very pleased to be here today to talk to you all. Next slide, please. So I just want to briefly touch on the water resources that are available to us in Shropshire. And this slide shows the river network in Shropshire, the main rivers, with the River Severn shown in a darker blue. The River Severn supplies 6 million people, not all of them clearly in Shropshire, with water, plus abstractions for agriculture, industry and navigation. Now, in order to abstract water from a river for various uses, you need a licence. And our area is actually over-licensed and over-abstracted. So there is actually a shortage of water, and various users would use more water if the Environment Agency would permit them to do so with a licence. The key pressures on the river system are in the summer. That's the time when evaporation means that much of the rainfall that falls on the ground doesn't actually reach the rivers because it's so hot, but also the requirements for agricultural demand in particular, where you need irrigation during the summer months and the growing season, the demand is very high. And of course, too much abstraction means that there are then low flows in the river, which puts pressures on ecology and habitats. And this has been a real problem in the River Severn. Next slide. Many people don't actually realise that groundwater is also an important source of water. You can think of groundwater as water that is held in the pore spaces as in rocks, much as a sponge, if you put it underneath water, will hold water in the little pore spaces. Rocks act in the same way. So when it rains, water will infiltrate down the rocks and drain down until it reaches the water table. And that's the level below which the rock is saturated. So rocks that can store and transmit water in this way are known as aquifers. And the figure here shows in yellow, orange, and a little bit in blue, the main important aquifers in Shropshire. Groundwater can be pumped from the ground using boreholes, and the biggest abstractions in our area are where the major aquifer areas are, although there are numerous small abstractions and springs used for agricultural supply across the entirety of Shropshire. I'll just briefly mention the Shropshire Groundwater Scheme, which other speakers are going to talk on more a little bit later. It's a series of boreholes that are used to draw water out of the key aquifer and top up the River Severn at times of low flows. So quite an ingenious scheme that's running here in Shropshire. So that's a very brief introduction to the water resources available to us. And I now want to turn to the first of our environmental themes, which is climate change. At a first glance, it may seem that water doesn't have a particularly big role to play in the fight against climate change, but actually it has a crucial role to play in forming and maintaining peat and wetlands, which are much better, in fact, than forests for retaining carbon. In a peaty environment, organic material is too wet to rot and release its carbon, so the carbon stays trapped and forms peat. Conversely, when peaty environments are damaged by drying out, there can be a very significant release of carbon as the organic materials break down. Even worse, if these environments dry out enough to catch fire, then you can have a catastrophic release of carbon by burning and wildfires. The photographs that I've got here show the stiper stones, and the figure at the top shows the green areas are our upland heathland with the stiper stones and the long mint. And I want to draw your attention really to the big contrast between the heathland landscape and the fields. For centuries, the fields have been drained by various methods, but in the 1970s, there were big government grants for farmers to drain the land for sheep grazing. And you can see the huge difference this has made to the vegetation cover. So under drainage, where the entire field is laid with a blanket of pipes, and big ditches carry water rapidly away from the land in response to rainfall, and this land did have the potential to be peat forming. So it's clear that land and water management in the Shropshire Hills has a direct effect on climate change. And now all sorts of parties, including the Area of Outstanding Natural Beauty and the Wildlife Trusts, are undertaking various re-wetting projects, which are, at their simplest, simply trying to break field drains and try to keep water on the land. So these are some quite low-tech ways, but effective ways of using water to battle climate change. Next slide, please. So one of the key pieces of old technology that we use to monitor water levels in heathlands and wetlands through a borehole is by a dip meter, which is the sort of red device you can see there. It's a wire on a reel that you lower into a borehole, and it beeps when it hits the water table. Very simple. Slightly more sophisticated is a piezometer, which is lowered below the water table and measures the height of the water above it. And these can be left in a borehole and connected to a data logger, which then can transmit or store data. And if you're in an area with good networks, you can then transmit that data to the cloud. Now, clearly, that does not necessarily work well in a rural or remote environment. But recent advances in communications and in power mean that these systems are now being applied in much more rural settings. So LoRa, or long-range radio, is a low-power wireless platform that can transmit data in areas where there's poor mobile coverage. So once you've transmitted this data to a hub, it can then be uploaded to a cloud and accessed from anywhere in the world. It's a low power usage, so that means that improvements in solar technology and in battery technology mean that these units can now actually be self-sustaining in terms of deriving their own power, so they actually have minimal need for human interaction, which is great news for rural settings where you need to know about water level changes. Next slide, please. The second of my themes is on habitat and biodiversity. Now, obviously, most habitats need some water to thrive, but there are some that are particularly water dependent, such as wetlands and bogs. In Shropshire, the most well-known of these areas are the Fens and Wixall and Bettisfield mosses up in the north near Whitchurch, and they are outstandingly beautiful areas. Also, the old riverbed in Shrewsbury is a similar wetland formed by different means. Now, these systems are really important for maintaining a relatively rare ecosystem of plants and insects. And as stated earlier, they're also very important for storing carbon. The mosses have been damaged by peat cutting in the past, but now they're being managed and restored by Shropshire Wildlife Trust. Next slide, please. Next slide, thank you. Now, a very interesting technological innovation in the last couple of years has been the application of UAVs to wetlands. UAVs are unmanned aerial vehicles, better known as drones. And the graphic on this slide shows some data from research using drone technology to map wetlands in the southwest of Spain and Romania. The researchers here, and the details are on the slide, undertook a number of transects across the wetland to get themselves some real survey data across the area. And then they were able to draw some really effective correlations between what the drones measured and what they measured in real life. And in this way, they could measure things that were important, such as the depth of water, pollution, and the percentage cover of open water, and things like emergent plant species. And then using those correlations, they were able to map the whole of the area using the UAV, which would clearly be just not possible using sort of normal technology. Now, this sort of remote sensing has been used for a long time now based on land-based systems, but these authors were particularly pleased to have made some breakthroughs in using the technology to tell them some useful things about wetland sites. Next slide. The third theme I just want to touch on briefly is water as a resource. Clearly, water is important for domestic drinking water supplies, the water that you and I get out of our tap at home, but it's also important for agriculture, industry and recreational use. Agriculture, industry and recreation obviously can derive their own water from various abstractions. From surface water and groundwater. But if we concentrate a little bit on the water that is supplied by Severn Trent Water, our local water undertaker. Now, Severn Trent Water have an area that is far bigger than Shropshire, and the graphic here on the right shows Shropshire in red and some of the subcatchments of Severn Trent's area in blue. Severn Trent obtain about 40% of their water from river abstraction and 30% from groundwater, and then 30% from surface water reservoirs. They treat this water and then send it on to our homes. Now, the graph at the bottom of the slide shows the projected water balance for different supply zones. And we're in the Severn Water Resource Zone, which covers most of Shropshire. And it can be seen that in 2010, there was projected to be quite a large deficit of water. So actually the requirement and need for water in our area outstripped the amount of water that was available. And the projections in the same report showed that there was projected to be a similar deficit going forward to the present day. Next slide. Now, there are various ways to combat a water shortage or water deficit. In the long term, water operators can make plans to store or import water via new infrastructure. And there's also a really big undertaking nationwide to minimise leakage from water supply pipes. For a long time, particularly in the southeast, managing demand has been a big area of improvement for water companies. For example, some residents are given rubber bricks to place in their toilet systems so they don't flush so much water down the drain. One interesting project I wanted to mention was run on research by the University of Exeter, and it was a smart rainfall management system, and that's shown in the bottom photograph there. The roof drains were connected to tanks, which could then be used for watering the gardens, thus reducing the demand for mains water. But the smart bit of this project was that the water levels were monitored and the weather forecast was used so that the tanks actually emptied themselves before a major storm event. And in that way, the storm event water was stored and the sewers weren't inundated with water all at once. And this project was a number of projects under the Future Cities umbrella. And these take the idea of ubiquitous monitoring, where all sorts of little gadgets are talking to each other and monitoring things all the time, generating lots of big data that's then available in real time, either for people to use or for automated systems to take action in response to their various events. And these kind of projects rely on the Internet of Things. As I said, lots of gadgets sending and receiving data, speaking to each other. And these kind of projects can also use the long-range radio that I talked about earlier. Next slide, please. The fourth theme is pollution. Pollution can obviously affect water quality, making it unfit for purpose and reducing the amount of water available to us. And it could also have a highly negative effect on habitats and biodiversity. Just touching briefly on agriculture, due to the fertilisers put on land, nitrates and phosphates can be a big problem in water. And these are really good nutrients, which means that they feed algal blooms in the water, and these can consume oxygen and threaten other aquatic life forms. And the top picture in this slide shows a bioreactor, which is a piece of research that's currently being undertaken by Research and CREST. It's kind of low-tech technology, just simply a pit filled with some kind of reactor, such as sawdust. And the idea is that you feed the field drainage through a simple vessel like this, and the resulting effluent has far less nitrate and is sent on its way to the nearest stream. Touching on industrial pollution, we may not think that Shropshire has much of an industrial legacy to create pollution, but the photo at the bottom there is a reminder of the lead mines near Snail Beach, where decades and centuries of mining resulted in big lead tips and pollution of the water supply and the land around. The tips are now remediated and the local community on mains water supply. Two other key contributions to pollution are landfill and sewage, and I just wanted to talk a bit more about sewage as it's very topical at the moment. So next slide, please. Combined sewage overflows, or CSOs, are in the news a lot at the moment. And this is where, in response to high rainfall and high volumes of water going through the sewage system, raw sewage is allowed to go straight into the river. There's currently a bill going through Parliament to reduce this, and Shropshire Wildlife Trust have been very active in campaigning to raise awareness and support. The top picture here in this slide shows the CSOs that are active in Shrewsbury. One of the key aspects in terms of controlling these overflows is to get good data. So again, we're back to smart technology. In the lower photo shows the little blue monitoring device, a hydrologic monitor. These systems rely on smart technology, gadgets speaking to each other and uploading data to the cloud. So in this way that you can monitor a whole network of sewers and the data analysed and triggers set for alerts so that you can take action in response to specific events. But also you can see from a system like this where the stresses are in the system, so you can use it to plan future infrastructure. Next slide, please. This is just another example of a sort of high-tech water quality monitoring system. It's a site that I was involved with in Hertfordshire, and we used a series of probes placed into a borehole to measure groundwater parameters, water level, conductivity, turbidity, water temperature. And these data were then relayed to the cloud via the mobile network. And the project team could view the data pretty much in real time from anywhere in the world. So that was fantastic. And this particular project was focused on whether piling for a development in a chalk aquifer would affect water quality at a local public water supply borehole. Next slide, please. The fifth theme to touch on is flooding, which of course we're all too familiar with in Shrewsbury and indeed across many areas in Shropshire. Climate and river level and flow data are of course in regular use across many areas to predict floods and flood levels and to help plan and design conventional engineering solutions to flooding. I wanted very briefly to introduce a newer and complementary approach to flood management, which is natural flood management, or NFM. And these are fairly low tech and low engineering systems put in place in lots of places higher up in the catchment. And the middle left photo here shows a woody dam as an example. And we have a fuller talk on this later in this morning's programme. Another key tool in the fight against flooding is sustainable drainage systems, or SUDs. So most developments will introduce hard surfaces with drains, which means that rainfall drains off the land far quicker than on undeveloped land and then can contribute to peak flood flows. So in essence, SUDs aim to store and retain rainwater on a site instead of sending it straight to the sewer. And the bottom photo there shows a swale on a development site where water is being stored. And that has capacity then to store a large rainwater event and then release it much more slowly. Another benefit of this system, of course, is that it can help reduce the combined sewage overflows we talked about earlier, but also the very fact of storing water in such an environment can help reduce pollution due to particulates falling out and chemicals degrading whilst they're being stored on site. And the smart rainfall system that we looked at earlier also was a kind of system, as well as reducing demand for water. Next slide, please. My final theme is drought. So in Shropshire, drought hits the agricultural sector quite hard, particularly as most farmers have strict limits on the amount of water they can abstract from surface or groundwater, as we spoke about earlier. And high demand comes at times of low river flow during the summer. The map here shows areas of high irrigation demand, and we're the sort of orange blob in the West Midlands. So there are some well-known technologies for managing water on farms, such as storage of winter abstractions for use in the summer when the demand is higher. More recently, climate smart agriculture is a set of concepts developed around producing increasing productivity on farms whilst adapting to climate change, but also using farm management techniques to mitigate climate change. And whilst these concepts are generally applied in developing countries, the same concepts are equally as valid really to Shrewsbury, and more so as climate change progresses. Smart irrigation technology is also something that's continually developing as the Internet of Things advances. Imagine if you can imagine measuring soil deficit in real time and then having a targeted irrigation system that can put water where it's needed, when it's needed, and that will dramatically decrease water consumption. Next slide. So in summary, the issues that we talked about this morning so far are very interlinked, and we'll go on and hear more about various of these later this morning. So for example, the way that we drain and manage land can combat climate change and support water-dependent ecosystems, but can also mitigate flooding, help prevent pollution, and reduce the demand for mains water supply. In reducing the demand for mains water supply, we can reduce water abstraction, which in turn reduces water pressure on river ecosystems due to low flows in the rivers, and improves the amenity of water use for recreation. So things are very interlinked. We see that the Internet of Things, networks of smart gadgets communicating with each other, can be very effectively used to monitor and manage all sorts of systems from irrigation to sewage networks. And in the future, I'm sure it will be used even more to optimise the interlinking between these systems. Technological advances in power supply and communications are now making these systems available and sustainable in rural and remote environments. But we've also seen that low-tech technology is equally as important, for example, in natural flood management, bioreactors, and re-wetting systems. And perhaps we'll see a more joining up of these systems in the future. You can imagine a natural flood management system that stores water for use in the summer, perhaps transferring water to a neighbouring farm, with an ultimate outfall from a drainage system that went through a bioreactor to improve quality. What is certain, I think, is that there are some serious issues facing Shropshire in terms of climate change, water use and management, and the impact on the environment, and that Shropshire has a key role to play in finding solutions that work here on our patch, but may also be applied elsewhere throughout the UK. So the technologies and themes that I've talked about this morning are certainly worth exploring further. And we've got lots of interesting talks this morning that will do so. Many thanks.
Super, thank you so much, Hannah. That was really interesting. Great summary of everything that's going on in Shropshire. I'm just checking the Q&A. There's no questions, but I've got a couple.
Yeah.
Please come in. Everybody's very happy, all clapping. Great. Just some really simple questions, actually, because as you know, I'm not a water expert at all. So, do you think that we can reverse what has happened to our upland, heathland, blanket bogs and peatlands to mitigate effects against climate change going forwards?
Yeah, there is lots of work being done in peat restoration. Peat bogs don't tend to, once they dry out, they can develop cracks which then transmit water really quickly. So they don't tend to self-heal very well. But you can just, put the right sorts of material back in those cracks, and that then can help them heal. So those sorts of restoration projects are underway. But the slightly wider question is, if you're a landowner that's grazing sheep that makes some money, what's your incentive then to turn your land over to a peat bog? And I think those land management questions are really around government policy, and it comes into ecosystem services and who effectively is going to pay for the carbon capture potential of that land.
Maybe Elms needs to include that. I know we've got a colleague on the call today from the NFU that might have a view on that going forward. We've got a question here from Chris Taylor. Where does tree planting fit in the urban development landscape with regards to flooding? Should we be planting more trees in towns?
I have to say I'm not an expert on this, but my sort of personal view is absolutely yes, for all sorts of reasons. Water interception is a big one. Transpiration, the trees consume a lot of water, but have a big role to play in all sorts of other areas as well, don't they, in terms of clean air, amenity, biodiversity. So historically, there's been some resistance to trees in towns from the authorities that have to clean up the leaves and deal with the roots that break up the pavements and those sorts of things. And I think that those issues should be out in the open, and we should recognise that if we're going to have all the benefits that come with trees, then we need to be absolutely ready to deal with the issues of leaves and roots.
Yeah, absolutely. Thank you, Hannah. I've got one more question from Paul Lindop. Do any of the peatland and upland areas feed into drinking water supply in this area? Treatment can generate byproducts. So do any of the peatland and upland areas feed into drinking water?
Well,
in this
yes,
area?
there is a reservoir in up near Church, isn't there, that is derived from the peat and upland areas, but also lots and lots of farms and homesteads in the more rural and remote areas use springs that still feed quite a lot of communities, actually, especially in South Shropshire. Yeah.
Okay, and one more before we move on. This is from Vicky Ayton from CREST. If you had to choose one priority to focus on in Shropshire, what would it be?
Oh, interesting. Well, hopefully I've sort of suggested that they're so interlinked that if you choose a good one, you'll affect all of these things. And I think it would come under the heading of land drainage, probably, both in the rural environment and in the urban environment. So if you're getting the way you drain land and store water on land, whether that's NFM in rural areas, land drainage, re-wetting projects, those can help with not just preventing flooding, but also creating a source of water, that's great in the rural areas. And then in the urban areas, if you're actually dealing with land drainage through SUDs, smart rainwater systems, those kind of things, that can help deal with water demand and water quality, and issues such as the CSOs. So yeah, I would say it would be kind of land drainage management. I think you're on mute, Juliana.
That's what we were saying earlier. That is the we have got a couple more questions. What we'll make sure we do is forward those questions to the relevant speakers so they can be answered, if that's okay with you, Hannah.
Yes.
Okay, cool. Thank you ever so much again for your presentation.
My pleasure.
Okay.